Alright, so, hey everyone, welcome back to Mathelingual. Oh, okay. Mathematics, not how to not be clumsy. Okay, so, what we're going to talk about now is the question, is an equation always, sometimes, or never true? So, I'm going to elaborate that on a little bit. So, think about it this way. Sometimes when you have an equation that has a variable, sometimes you solve for the value of that variable, but it turns out no value makes the equation true. So in that case, the equation is never true for any value of the variable. But sometimes you have a special case called an identity, okay? That is an important term to know. Identity, where any value of the variable will make the equation true. Any value of the variable, okay, I talk a lot faster than I write. Any value of the variable will make the equation true, okay? So you'll see a few examples of that in a moment, but I just want to highlight that. And by the idea of always true or sometimes or never, I'm going to give an example because the examples I'm going to touch base on focus on the first and last of this phrase. Okay, so we're going to be focusing on this and this, always and never. But sometimes, I think, sometimes true would be like, let's say you have something that has a certain number of values. So like, let's just say, for example, I don't know, a really simple equation, like 2 plus x equals 5, okay? X equals 3 because 2 plus 3 equals 5, right? That is an example of an equation where it is sometimes true, right? If x equals 3, then it's true. But if you plug in something like x equals 1, that's not going to make it true because 2 plus 1 is not equal to 5, right? So it's a sometimes case. Or, I don't know, if you were solving for like a square root, like the square root of 25 equals x, so x equals 5, but it can also equal negative 5, so you could just write this as plus or minus 5. Right? So there are two solutions in this example, but it's still a sometimes case because you can't just say square root of 25 is like 9, right? Because that's not true, right? So this is a sometimes case. I think, well, my interpretation of it anyway is that a sometimes case compared to the always true and the never true cases is where you've got certain values that actually even make the equation true. So just a little tangent on that. All right, now let's delve into our examples. So, example 1, kind of a mouthful. 11 plus 3x minus 7 equals 6x plus 5 minus 3x. Okay, so what we're going to do, we're going to combine like terms on both sides, then simplify it to see what the equation turns out to be. Okay, so 11 plus 3x minus 7 equals 6x plus 5 minus 3x. So 11 minus 7, that's 4, plus 3x equals, on the other side, 6x minus 3x, that is, well, we've got that 5 there, right? So 6x minus 3x is 3x, of course, and you can just subtract out the 3x's. I know when I started learning these kind of equations, I used to get a little confused of what to do when you have a variable on both sides. So often out of mistake, I would try, maybe not so much out of mistake, I would try subtracting the constants, but really, as in this case, it's just simpler, just subtract the variable terms. So in this case, you've got 3x on both sides, just subtract 3x out. So we're left with 4 equals 5. Eee, that is not true. 4 is not equal to 5, right? I mean, if 4 is equal to 5 times some fraction, right? What's it? Oh, yeah. 4 is equal to 5 times 4/5. So if we had something like 4 equals 5 times 4/5, right? The 5 would cancel out. But this is just 4 equals 5. That's not true. So I'm going to put this mark. That is not true. So this is never. This is a never case, right? Do not say this is true because it is not, if it's not like 5 times 4/5, okay? So this is never true. That just means there is no solution to this equation. That means no matter what value of x you plug in this, you're never going to make the equation true because that is what it simplifies down to, because the x terms cancel out. So you're just left with two constants that are not the same. Okay, I think we're clear on that. Now, next example, number 2. 6x plus 5 minus 2x equals 4 plus 4x plus 1. Okay, we're going to apply a similar principle here. So I'm going to combine like terms on both sides. So 6x minus 2x, that gives me 4x, and you've got plus 5. 4 plus 1 is 5, and then 4x plus 5. Okay, looking pretty good so far. Subtract the 4 x's from both sides, and you get 5 equals 5, because those x terms cancel out. 5 equals 5. Okay, that is true. So this is an always case. This is your example of an identity, okay? Like I mentioned, this is an identity because you can plug in any value of x in this equation, and you are always going to make the equation true, because without substituting anything in for the x terms, you already have a genuine true statement. 5 equals 5. So this is an identity, and that means any value will work, will make equation true. All right? Okay. Yeah, that's pretty clear there. Okay, I'm just gonna erase some of this stuff up here, because I think we're getting the gist of defining an always case versus a sometimes versus an identity. Now let's check it out with my last 2 examples. So, example 3, 7x plus 6 minus 4x equals 12 plus 3x minus 8. Okay, again, look for the like terms on both sides. 7x and negative 4x, 12 and negative 8. Okay. 7x minus 4x is 3x plus 6. 12 minus 8 is 4 plus 3x. Subtract the 3x terms from both sides. 6 equals 4. No, that's wrong. That is not true. So this is a never case, which means no solution. And this is just how they write solution shorthand. Learned it from my chemistry class. But yeah, okay, let's double check. Yep, 7x minus 4x, that would be 3x plus the 6. 12 minus 8 is 4 plus the 3x. Subtract the 3x's. 6 is not equal to 4. Okay, last example. 2x, this one is a little bit stranger looking, depending on how you look at it, I guess. Because it involves a little bit more distribution, as you can see already on the left-hand side. 2x plus 3 times the quantity x minus 4 equals 2 times 2x minus 6 plus x. Okay, first off, before you try to combine like terms or anything, do the distribution first. It just makes it so much easier. 2x plus 3 times x minus 4, 3x minus 12 equals 4x minus 12 plus x. All right, let's double check. 2x, 3 times x is 3x, 3 times negative 4 is negative 12. 2 times 2x is 4x, 2 times negative 6 is negative 12 plus x. All right, now we're ready. So I'm going to take out those parentheses so we can just start on with the actual solving. Okay, 2x plus 3x, those are my like terms. 4x and x, those are also my like terms. 2x plus 3x is 5x, then you bring down the minus 12 equals 4x plus x is 5x. See where I'm going with this? Minus 12 is, yeah. So subtract the 5x's, although you should get an idea of where I'm going from here, because they are identical. Negative 12 equals negative 12. So this is a case of always, as in you plug in any value of x, you're going to get a true equation, which means it is an identity. Okay, so that wraps it up for today's video. Hope you found this helpful, and until then, see you next time on Mathelingual for more algebra, more mathematics. I'm Maya. See you then.